Question 7 in the 2019 Leaving Cert was a Cantor set question where you have the line segment 0 to 1, and at each next stage of the process you remove the middle third of the lines that are left. So you can see here, so the middle third here you can see is gone from the line above, and this line here has the middle third removed to give us these two, and similarly over here and then down here with these sections here removed from above. So what does the question ask us? It says complete the table below to show the length of the line segments removed at each step for the first 5 steps. So let's see how much is removed for each of the first 5 steps. So this is the table we were given. We were given the answer to the first stage, 1/3. So there's a relationship here between the bit that's left and the bit removed. In the next stage there was 2/9. So you can see here there's 1/9 left at the beginning, so there's 2 of them removed. In the next one, the first number here, 1/27, you can see I've marked 1, 2, 3, 4 of them removed. So 4/27 will be in step 3. And now can you see the pattern? From 1 to 2 to 4, you multiply by 2 on top, and on the bottom 3 to 9 to 27, you multiply by 3. So we're going to have 4 by 2, the next stage 8/27 by 3, 81. And then 88 by 2 is 16, and 81 by 3 is 243. And these are 2 to the power of and 3 to the power of. So 8/81 and 16/243. Okay, part 2 of this question, find the total number of all the line segments removed from the initial line segment of length 1 unit after a finite, and they tell you n number of steps in the process. Give answer in terms of n. So we know the sum of n terms is going to be a times 1 minus r to the power of n over 1 minus r. So we just need the ratio and we need a. Well, a has to be 1/3, the first term. And what are we multiplying by? Well, we said already we're multiplying by 2 on top and 3 on the bottom. So the ratio, that's that 2/3. So just fill your values in. 1/3 by 1 minus 2/3 to the power of n divided by 1 minus 2/3. So on top we're going to get 1/3 times 1 minus, well, we could write 2 to the power of n over 3 to the power of n, but we leave it as 2/3 to the power of n for now. And on the bottom, 1 minus 2/3 also gives 1/3, so we can see that these are going to cancel, and we're left with the answer of 1 minus 2/3 to the power of n. So part 3 of this question, find the total length removed after an infinite number of steps. Well, we know in the geometric series, if we want to say add the first 5 terms together, we put in 5 for this n here. Now in an infinite number of steps, if we imagine that the r is 2/3, 2/3 to the power of, say, like 1,000 is a tiny number, a tiny number. So what we say is that as or as n tends towards infinity, or to the power of n tends towards 0. So that's why the form which is given in the table is for the sum to infinity, or an infinite number of steps. If this is going to disappear on us, it's going to be 0. We're just left with a times 1, or we're just left with a over 1 minus r. So that's this formula that we're going to use now. So a is 2/3. Sorry, no, a is 1/3. R is 2/3. A is 1/3 over 1 minus 2/3, which you can see is just going to be 1/3 over 1/3, which is equal to 1. Part B of this question, you're asked to identify the endpoints A, B, C, D, E, F. I'll do it up here just so we can see the graph and I don't have to draw it out again. Okay, A. Well, this is 1/3 and we're jumping the same distance to A. So A is going to be 2/3. B is this point here. So B is 1/9 and jump the same distance again. We're going to get to 2/9. C is on the same line. Well, if we deal in ninths, we have 2/3 at this point. We're jumping a ninth. So 2/3 is 6/9. Jump 1, we're going to get 7/9. D again is on the same line, 7 over 9. We're just jumping the same distance again to D to get 8 over 9. And then where are we going down to? E is down here. It's this point here, the one on the right hand side. And we're dealing in 27ths, so we can actually go back from a third. If we go back, we have to go back 1, 2. So we're at 9 over 27 at this one. So we're going back 1, 2 to get to 7 over 27. And then F is it the one? It's the one on the left. It's this one here. So we're dealing in 27, so we're at 27 over 27 here. 1, 2. Actually, let me just double check. F is actually the one. It's this one. It's the one on the right of the two. So it's 27, 26, 25 over 27. 25 over 27. So they're the endpoints. Part 2, you're asked to give a reason why a third minus a ninth plus a 27th minus 1 over 81 is a point on the Cantor set. And let's look and see what this gives us. We're dealing with the next line down from the 27s. It's dealing with the 81s. So what do we have here? We have a third, which is 27 over 81. A ninth is 9 over 81. 27th is 3 over 81 and minus 1 over 81, so that's 27 and 3 is 30 minus 10, so 20 over 81. Well, we can go back up here and have a look. Where's this going to be? 20 over 81. Well, 21 over 81, sorry, 21 over 81 is going to be 7 over 9, and I think we had that as one of our values, did we? So 7 over 27, not 7 over 9, 7 over 27, which was E. So let's have a look. Point E is this one here, which was 7 over 27. So if we divide that one up into 3, we can see, let's just go down here. Point E was here, and it was 7 over 27. So if we divide that line up in 3, take the middle part out, and just go back up again and have a look. So point E was here, and then there was a jump. Point B was above this one, and point B was 2 over 9. So we have 2, that's 18 over 81 for B. And E, we said, was 21 over 81. So let's have a look. 18 over 21 and 21 over 21. We'll end up with E. It's on the right hand side. So that was 21 over 21, 81. So this one will become 20 over 81. This one will be 19 over 81. This will be 18 over 81. So we can see that 20 over 81 is this point here. So it's a point on the Cantor set. Or we could say that as 21 over 81 is a point on the Cantor set on line above. When we go down to the next line, which is the line where it's 81, the one before 21 would have to be a point on the Cantor set because the line gets divided up into 3. So that's 21, the one beside it will be 20. So the last part of this question, you're told the limit of this series, a third minus a ninth plus a 27th minus is a point on the Cantor set. Find this point. Well, the limit is going to be the sum to infinity. So it's going to be, again, the limit is going to be a over 1 minus r. And what have we got here? A is a third, the first term. And the ratio, am I multiplying by minus a third every time? Minus a third. The ratio is minus 1 over 3. So put that in, a third over 1 minus 1 over 3 is a third divided by 1 plus a third divided by 4 thirds. So the denominators cancel and we're left with a quarter. The Cantor set question.